Welcome to all. Today's class, a special type, moment of inertia for rhombus and diamond sections, required for strength of materials, where means see, especially in bending and shear stresses, for beams, there further, especially for shear stresses, this rhombus and diamond sections are required. It's a very popular bookwork is there. See, you might have observed here, those who have studied strength of materials, the shear stress distribution comes like this, maximum, not that way, okay. It will come this way. This is a tau neutral axis. You will get V by A. Somewhere here is tau maximum, not fully to the scale. Okay, little further. This is tau maximum. This is also tau maximum. That will be equal to 9 by 8 V by A. And the distance from here will be 1/8 of the total height. Total height is there, 1/8. This is a very popular bookwork, but practically not important. But strength of material and plastic analysis, there they will ask question for shape factor. When I do plastic, I will do it. Answer will be 2. To get that 2, derivations will be asked, some examinations, and also competitive examinations. Just they will ask you one line question. Therefore, that's why I am covering here. See, when I go to strength of materials or plastic analysis, or if I conduct classes for competitive examinations, I will tell at that time, when you require moment of inertia, go back to my earlier class in engineering mechanics. I will remember the class number so and so, lecture number, part number and lecture number, study and come back. See, people should be ready to go back and study. Okay, now this is just to understand only. Now see, first of all remember, I don't have to tell much about it. What is rhombus and diamond section? See, both rhombus and diamond sections. The diamond is not the diamond you get in the market, not that one. Shape, diamond sections. I won't sections. See, I use word sections because it is area here. Engineering mechanics, area, but strength of materials or section. Sections are quadrilateral. First of all, first property, they are quadrilaterals, and further, they are parallelograms, and with all four sides equal. Now, I will further tell, this is general, this is for both rhombus and diamond. See, for both rhombus and diamonds, they are quadrilateral first of all. Quadrilateral means four sides are there, further parallelograms, and further all four sides are equal. And how is the shape here? Here, one of the diagonal is horizontal and other diagonal is vertical. Of course, someone will tell, suppose this, sir, is it not diamond? Yes, correct, but strength. This is from subject point of view. Not otherwise. Subject point of view. See, people are there to ask question. Suppose they are not, see, suppose this is inclined, This is inclined. Is it not a diamond or rhombus? Yes. But then you have to look this way. General shape. See, now I will tell one by one. How is the rhombus? See, all four sides are equal. See, all four sides are equal means it is not square. It need not be square, because in square properties, all four sides are equal and both diagonals are equal. So, if all four sides are equal, and both diagonals are also equal or same, then it is called a square section. Square. See, let S be the side. Okay, now I am noting. First of all, make a note. I am explaining rhombus now first. I am first explaining rhombus. Okay. If all four sides are equal and both diagonals are also equal, it is a square. See, it's somewhere here. First of all, not to be told. This side is yes. Let yes be the side. Okay. This also yes. And see, these are the two diagonals. Where right diagonal? I'll show diagonal here. Okay, 1 minute now. I'll show yes here. Yes here and yes here. And see. This is the diagonal. I will take D. And other diagonal is this one. See. This is other diagonal is somewhere here. See. Okay. Let S be the side somewhere here. Let S be the side. Other diagonal is here. See. This one. This is diagonal D. Diagonal D. D I will use. I won't use small d because small d I am using for depth. This is the diagonal D. This is diamond section. Rhombus section. Now, if you go further for rhombus section, okay, 1 minute, I will tell for, now I will go for diamond section. Diamond section is also, this also, see, if all four sides are equal, here also, all four sides are equal, comma, and also it is a parallelogram. It is a quadrilateral, but diagonals are not equal. Not equal. Okay. So let D1 and D2 be the two diameters, something like that. Diameters. Okay, now further. This I will remove now. To understand correctly, make this note. First consider rhombus section. Rhombus. Property of the rhombus here. Rhombus. Make a note. What usually in strength of materials, etc., we write, or plastic analysis, we write rhombus means it's a square section which is placed with one of its diagonal horizontal, other diagonal vertical. See, I'll show you somewhere here. See, you see here, this is a square section. See, this is a square. Now, you place like this. See, this way. One diagonal horizontal, other, see, all four sides are equal. This diagonal equal to this diagonal, and with one diagonal horizontal, other diagonal vertical. Therefore, for a rhombus, see, originally square, see here, originally, this is yes, this also yes, and this diagonal D, this diagonal also D. All angles are 90 degrees, you know it, D. Here, turn it. See, same length. This will become now rhombus section. This is actually square section. Rhombus also square. Structural point of view, square section means you place like this. Otherwise, rhombus also is a square only, see. Or rhombus section from subject point of view is the same square section. You turn it, rotate it by 45 degrees. Rotate by 45 degrees. Then see, right here, rotate by 45 degrees. See, 90 degrees here also, this way. 90 here, 90 here, 90 here, 90 here. If this side is yes, this side also is yes. This here, see, one of the diagonal horizontal, see here, one of the diagonal horizontal, other diagonal vertical. This is a popular one. If you further rotate also, it is a square section only. So, not exact to scale, manage it. Okay, now this is rhombus section. Now we want, see, when a question is given, see here, make a note. When a question is given, either side will be given for rhombus. When a question is given for rhombus, either side will be given or diagonal will be given. Diagonal will be given. Some will tell, sir, area can be given. Yes, if you give area, take root, you get the side because square. Or diagonal will be given. Only one side, all are equal sides, both are equal diameter. Then you now only learn side will be given, say yes, and diagonal is D. Now only learn if side given, how to get the diameter. So not, I'm sorry, how to get the diagonal, not diameter. Or if, see right here, if side given, how to get the diagonal, or if diagonal given, how to get the side. Now only learn it. I will not explain again and again. See. Diamond, I will come after that one. See here. Now consider rhombus section. Rhombus. What you will do? Side we will see, yes is the side. Yes is the side. Make a note here. All four sides are equal and D is diagonal. Diagonal. Make all four sides equal. Four sides equal and both diagonals equal. Diagonal equal, and also write one diagonal horizontal, other diagonal vertical. See here. How to connect them? See here. How to connect them? Two different ways are there. Later directly I will write the answer. I won't waste time when I go later. See, this is the sketch. See, this is side yes. This also side yes. This is diagonal D. Exact scale I am not maintaining. Little turned here. See, that you should not bother in my class. D. See, this is the diagonal D. Diagonal D. Now see, two options for you. Right here. Option 1. Option 1. You do this way. See, when you do a problem later, you stick to one of the options. Later, if it is not clear, you yourself are responsible. See. This is D. This is yes. This is yes. This is a right angle. Therefore, in this triangle, right angle triangle, D equal to square root of this diagonal, see, square root of S square plus S square equal to root of 2 times S square, or your D equal to root 2 times S. So, make a big note. Diagonal is root 2 times yes. See, surely diagonal is more than side. You should know it. Diagonal is more than side. So root 2 is more than 1. So the diagonal, both the diagonals are root 2 times yes. One option. Or I'll go for option 2 here. Both are same. Option 2. Actually waste of time. See. Okay. Somewhat agree. Don't bother. You divide like this. See here. This is side yes. This full is diagonal D. Diagonal. This also full is diagonal D. You take right angle triangle here. See here. This is 45 degrees. Now you connect here. Sin 45 equal to this side. If this is diagonal, this will be diagonal by 2. It is d by 2 divided by s. Or you can tell d by 2, that is half the height or half the diagonal. D by 2 means half diagonal. Half diagonal is sin 45 is 1 by root 2. Everybody knows it. So is s by root 2. See, s into 1 by root 2, half the diagonal. Therefore, the diagonal equal to 2 times of s by root 2, or 2 by root 2 is root 2s. Over. Therefore, I will conclude now. I will not explain again and again to waste the time. See, for a square, for a rhombus section, for a rhombus, if remember that what? Diagonal, both are equal, both equal. Diagonal, any diagonal, see, any diagonal equal to side, or it is root 2 times side. Side, yes. Okay. One concept over. So if they give side, multiply by root 2, you get the diagonal. Or this is, use this. Or if by chance, see, rhombus, if side given, say yes, and we want diagonal. Or if diagonal given, say D, then if you want side, then side yes. You should know it. D diagonal is D. D equal to root 2 side, or if they give diagonal, the side equal to D divided by root 2. Why? Side is less than diagonal. So side is lesser, diagonal is more. So if side given, multiply by root 2, it will become more. You get it. Or if diagonal given, if you want side, divide by root 2. That's all. In now onwards, I will not talk about this one. Okay, this is for rhombus. Come to, so when I solve the question, I will solve, see, the purpose of this class is to help you for academic examination, and also for bending and shear stresses, and also for plastic analysis and computer examination. So everything go through. And now come to rhombus, but diamond section. Diamond section also is a quadrilateral. It is also, it is parallelogram with all 4 sides equal. But note, diagonals are not equal. Diagonals are not equal. So angle is not 90. So there are total 4 angles are there. 2 of the angles are more than 90 degrees and two of the other angles are less than 90 degrees. If all are 90 degrees, it becomes what? Rhombus only. See, now, or see here, this is a diamond section, rhombus section. You can do one thing, you pull it this way, pull outwards. These two will come inward, this will move outward. See here. Somewhat okay, reasonably okay. This is square section, square, just to understand, you do one thing. These two opposite push inwards. These two opposite pull outwards. See now, this is your diamond section. Diamond section. See, I will take the horizontal diagonal as D1, vertical diagonal as D2. Horizontal diagonal D1, vertical diagonal D2. Or see, usually diamond means this is bigger. Need not be. Even this also diamond only, see. Here, see, bigger one, smaller one. See, here, this angle is, these two angles are, see, less than 90 degrees, and these two angles are, you make a note, more than 90 degrees. Or it is possible here also, see, this also okay. Okay, somewhat okay. Here, this angle is, this angle and this angle are less than 90 degrees. These two are more than 90 degrees. Now, here, this is D1, this is D2. Here I have put your D2 more than D1. Here I have put D1 more than D2. See, okay, little, don't worry, adjust it. So, horizontal diagonal is lesser here, vertical diagonal more here. Horizontal diagonal is more, vertical lesser. Actually, this is the most popular diagonal. And make a note. Now I will go for something else. See, for diamond section, if in question, always diagonal will be given, side will not be given, diagonals will be given. Always what? Diagonals will be given, side will not be given. And one more thing, see, further. In case you want side, see, sides are equal, then in case side given, then in question they should mention the angle. They should tell what is this angle, one angle. They should mention the angle. In that case, okay, you can calculate. Then use trigonometry. And get the what? If in case side is given, get the diagonal. Because reason for finding moment of inertia, we always require diagonals. That's why we want diagonal. Remember, see, make a note here. Both the cases for finding moment of inertia, we need diagonal. We need diagonals. So, if side given, get the diagonal. If it is rhombus, if side given, directly diagonal equal to √2 times side. Whereas by chance if diagonal given and if you want the side, it is diagonal by √2. In diamond section, they will always give you diagonal. But in case by chance side given, then they have to give the what? The angle. Angle should be given. One of the two angles are less than 90 and another two opposite angles are less than 90. Other two opposite angles are more than 90. They have to give it. Everything I will cover now. Okay. Before that one, first some important part I will give you. Irrespective of what? Either diamond or which one? Either rhombus or diamond common. See here. Irrespective of either rhombus or diamond for finding moment of inertia about centroidal axis, consider diameter and divide into two isosceles triangles. See, divide into two isosceles triangle. How? One upper side. See, I show you. When you want a moment of inertia, see, divide into two triangles. That is, one upper side and other lower side. This way divide. Okay. Remember now? Now I will start one by one. Now, question 84A. Find moment of inertia about centroidal axis for a rhombus section of side S. Start. Rhombus I told, side S, all are equal, angle 90, not rhombus section, class. I already told, for finding moment of inertia, you require the diagonal. So, any diagonal equal to root 2 times S. See, any diagonal, say D. See, say D. Any diagonal, say D. You can do one thing, you can mark here. You write the section once again here and write here. This is one of the diagonal. This is the other diagonal. Mark here. D. And also now only mark one more thing. Okay, leave it now. So, any diagonal equal to root 2S. Now, further, this is perfectly symmetrical about x and y. See, first of all, make a note, divide into two parts, one upper side, one lower side. Upper side I will take 1, lower side I will take 2. This is G2. Okay, write all this. Now see, this is diagonal is root 2s. Side s is not required. Okay, now I will come this side now. I will calculate I. Start Ixx. Now I won't explain anything. First write usual formula for I. If you do not know, nothing can be done now. Too late. If anybody will tell now, sir, how to find I means, right? We have I about any axis equal to thousands of times over Ig plus area into h square. When I require red color, is not coming. Okay. Into h square. Start. Now, I about xx. I will tell something. Somebody will be there who is watching. He will tell, sir does not know something. He does not know. I know it. I will tell you last. Okay. Start. First, I about its own centroidal axis. See, this is parallel side. This is isosceles triangle. Parallel side is root 2s equal to, see, calculate. Root 2s is one side into, see, parallel side into height. You should mark here. If the D is root 2s, you write somewhere here. I forgot to write. See, this is red color only. Total is root. This is what? This will be equal to root 2s divided by 2. Root 2s divided by 2 is s by root 2. Or I told you, see, s by root 2, half the diagonal. This also s by root 2. S by root 2 or equal to this isosceles triangle, full triangle, base root 2s into height s by root 2. Height is s by root 2 into s by root 2 cube divided by 36 plus area. Area is what? Half into d by root 2, root 2d plus some space problem is there. I start here. Space problem. Okay. Ixx. See. I about xx equal to, start once again. For upper triangle, I about its own axis, parallel root 2s. Root 2s is one side into s by root 2, see, base into height cube divided by 36. Why? This you know it's center of the axis. This is your Ig plus area, half into root 2s into s by root 2. Actually area is half of the square s square by 2. Okay, leave it. Half into very important, from here to here, this distance square is 1 by 3 of what? 1 by 3 of s by root 2 whole square. That will give I for the upper triangle. This full put in a flower bracket. Come, this is upper triangle, multiply by 2 because lower triangle is there. Identical or equal to, see here, equal to s into s power 4. See, s power 4 times, see, s power 4 outside times root 1 by 1 by root 2 cube. Root 2 cube is, sorry, root 2 by root 2 cube is root 2 square. Root 2 square is what? Root 1 by root 2 square. 1 by root 2 square is 1 by 2. 1 by upper side is what? Upper side is 1 by 2. Why? See, root 2 cube. Root 2 cube, 1 root 2 cancels here. 1 by root 2 square. So, becomes 1 by root 2 divided by 36 plus here root 2 cancels. See, s into s is s square into s square. S power 4 has gone outside. So, remaining is what? S by 2, see here, where is it? Not s by 2, root 2 cancels. 1 by 2 times 1 by root 2 square is 2. 3 square is 9. 9 into is 18. 1 by 18 or equal to s power 4 into, operate the calculator for this one. Take your calculator and operate. Where is my calculator? I don't know. It's here. See, it is 1 by 72 plus, a calculator is not on, 1 by 72 plus 1 by 36 is 1 by 24, multiplied by 2 is there. See, everything outside 2 is there, equal to, into 2, equal to, reciprocal, equal to s power 4 into 1 by 12 will come. Or you can tell answer s power 4 by 12 is the answer. That is I about xx axis. Actually, I about yy you need not calculate because it is same as ixx. But here it does not look same. Okay, s power 4 by 12 you got. Now go for iyy. We will do it. What is there? iyy. Start. First, about its own centroidal axis. Isosceles triangle, remember, for upper triangle, parallel side is s by root 2 into See, S by root is one of parallel side. S by root 2 into, see, I about yy, parallel into this side, perpendicular side for yy. Root 2s cube divided by, I told repeatedly, if anybody it is not clear, don't continue my class. If someone will ask, sir, about this axis you put bh cube by 36, about this axis you put hb cube by 48, why? Don't come to the class. Okay, that one. This is your ig. See, this is your ig. Plus area. Area is, okay, do one thing, plus area into this G1 lies in yy. Why want to waste time unnecessary? Into 0 square. Since it is 0 square, why should you waste the time of finding area? Okay, but multiply by 2. See, multiply everything by 2. That will give you, see here, s into s cube, s power 4 by 48 here. Then root 2 cube is root 2 cube by root 2. Root 2 cube, 1 root 2 cancels. Root 2 square. Root 2 square is 2. Then multiplied by outside 2. 2 into 2, 4. 4 by 48. S power 4 by 12 once again over. Therefore, I will put the result now in terms of S. So therefore, remember, result I am putting now. Then I will give a numerical for you. See, result. Therefore, result for a rhombus section, if side given, say yes, then remember your I about xx equal to I about yy equal to s power 4 divided by 12 is the answer. S power 4 divided by 12 if side is given, s power 4 by 12. Now, I will tell one thing important for you. If you, those who can understand, see, just for understanding purpose, not here, you consider a square section. See, square section of side S. Then, this is one of the centroidal axis, other centroidal axis. These two are called principal axis. And moment of inertia about one of them, property is there. The property of principal axis is moment of inertia about one of them is maximum and other is minimum, and moment of inertia about any other axis, any inclined axis passing to centroid will lie in between. For example, see, if this I is 100, if this I is 80, no, not for square, I am telling generally, see, actually both are equal here. If it is unequal, see, then maximum amount of inertia is 100. Maximum moment of inertia 100. Principal about centroidal axis, maximum. Minimum is 80. Now, any axis you draw in between, any axis you draw at any angle, moment of inertia will be between 80 and 100. That's a rule. That is called principal axis. Okay, now for a square section, see here, this I, you know it, how much? See, s into s cube by 12. S into s cube by 12 is s power 4 by 12. I about this axis also is s into s cube by 12 is s power 4 by 12. Oh, moment of inertia about both principal axes are equal. In that case, that itself is maximum and that itself is minimum. Therefore, both are equal means any other axis passing to centroid, I should be in between. It can't be in between. So that means I about, see, therefore, you write here for a square section, see, square section of side S and side S. Centroid is here. I about this axis is S power 4 by 12. I about this axis also equal to S power 4 by 12. I about this axis, about this axis, about this axis, about this axis, this axis, this axis, any axis, and I about all those inclined axes passing to centroid is also equal to S power 4 by 12. Correct? See here, this rhombus section is actually a square section, turned. See, turned. Therefore, you turn it, no problem. Therefore, in any question for a examination, if a square section given and they told it is provided, so section is placed so that one of the diagonal is horizontal, other diagonal is vertical, then directly you can write, when the moment of inertia comes, you don't waste time, you write, we know that for a square section, moment of inertia about any centroidal axis, either horizontal or vertical or inclined, everything is one answer, unique answer, S power 4 by 12. This is also valid for circular section, only for square and circular section, or any other section. Suppose you prepare, even hollow rectangle will do if the dimensions are identical in both directions. Therefore, if Ixx equal to Iyy, I about any axis passing to centroid is same. See, even after calculating also we got same. Okay, now question 84 over question 85. 84, this is what I did is question 84A last time. Now one exercise for you. Exercise 84B. You solve the question. Find moment of inertia about centroidal axis for a rhombus section of side numerical 150 millimeter. That's all. You solve. You side 150, you solve systematically. No, don't put formula. See, don't tell we know that. You write we do not know. You same way. You find the diagonal. What I did now, do the same way, and finally your answer will be, your Ixx will be equal to Iyy. See, your section is how? This way. Sorry, what is this one? Okay, this is 150, this is also 150. Answer is both are equal. You will get, some will tell, now we know what sir is doing. Sir is doing by formula. It is my wish. I will explain everything. 150 power 4 divided by 12. 42.1875, 10 to the power 6 millimeter power 4. You should solve same way, Ig plus A square. See, this is the test for you. When you solve the same way, see, your side will come, how much? Your side will come 150, sorry, side is given 150. When you solve, your diameter will, diagonal will come 150 into root 2. You write root 2 150 only, is root 2 150. Or if you do numerical, it is 212.132. But if you write 212.132, you will get 41.187499, something like that it will come. Decimal error. If you write root 2 as root 2 only, you will get same answer. Okay. This is for which one? 84 question. Now, question number 85. Again A and B. See, A. 85A. I am solving all the cases. 85A is a book work. A means book work. Find moment of inertia about centroidal axis for a rhombus section of diagonal, this time diagonal given, diagonal D over side not given. Okay, I'll solve first. See, so simple it is. Leave it. This time they told diagonal. See, how to solve? Consider section. See, rhombus section told your section is like this. See, exact scale I can't maintain here. This diagonal is D, this diagonal also D. Both are equal. Okay, no problem. Okay, when I write here, sometime it becomes slightly tilted. Those tilting all you should not bother. You should those who are studying, they will not bother. Okay, now start. It's not 90. It's been 90 degrees here. Don't mind. Okay, now reasonably okay. Further, I won't waste time. See. Now, divide into two triangles. See, one upper triangle, one lower triangle. Do from principles, lower triangle, right here. They told in the question, diagonal is D. So, write D here. If that is D, see, this also D. Because why? It's a rhombus section, D. And then, see, this is centroid, or last time I forgot here, centroid G for entire. I forgot to write last time, enter it here. So this is your XX and YY. See? Oh, what is this one? It is going this side, tilted. Oh, okay, no problem. If somebody will comment, let him comment. There is no time for G. See, this is G. See, when I write here, don't bother about those. You write D. If this is D, this also D. This centroidal distance both ways is D by 2, D by 2. D by 2, D by 2. Diagonal given, not depth. Okay, now start. I about XX. See what happens now. See, first mark its own centroidal axis. See here, G1 and G2. Figure number 1, figure number 2. Divide two triangles. Okay, upper side. I about XX. First, I about its own centroidal axis. See here, this axis is how much? Parallel side, D. D into perpendicular side, D by 2 cube divided by 36 plus half into D by 2 is the area, this area into this distance square is into 1 by 3 of D by 2, see, 1/3 of D by 2 whole square. Then without forgetting, this is for upper triangle, whatever you get, multiply by 2 or equal to, see here, D into D cube. D power 4 comes outside. 2 cube is 8. 1 by 8 into 1 by 36 plus D into D square and D square goes outside. 2 into 2, 1 by 4 into 1 by 3 into 2 is 6. 6 square is 36. 1 by 36 into 2 or equal to 1 by 8 into 1 by 36 plus 1 by 4 into 1 by 36. 1 by 96. It is D power 4 by 96. Into 2 I made? No, I forgot now. 1 by 8 into 1 by 36 plus 1 by 4 into 1 by 36 is into 2. Into 2 is D power 4 by 48. 48. Correct answer? D power 4 by 48. Okay. That is the answer. IXX. Now calculate IYY. Actually, IY was the same. See, first, I about YY. I forgot YY here. YY. First about its own centroidal axis. that is parallel side is d by 2. D by 2 into perpendicular side d cube divided by 48, not this 48, that 48. That is your Ig. See, this 48 is our usual isosceles triangle 48. This is the answer 48 you got, plus area. Whatever is the area into G1 lies in YY into what? 0 square. Okay, red color. 0 square. 0 square. Then without forgetting, multiply by 2. Why? Identical or equal. See here. 2, this is 2 and 2 will cancel. D cube into D is d power 4 by 48 or equal to d power 4 by 48 is the answer. Okay. Therefore, make a note, summary. Therefore, for a rhombus section, if diagonal, both, remember, you write here, diagonal is given, say D. Make a note here. What? Rhombus section, both diagonals are equal. Then your I about xx equal to I about yy. If they give side s, it is s power 4 by 12. If they give diagonal, it is diameter power 4 by 48. This 48 is not this 48, by 48. Okay. Or now do one thing. Let us check the answer. How to check it? Check is very simple. See, you do one thing. Let S be the side. Then you know that S equal to what? Side equal to diagonal divided by root 2. In that case, see here, your I will become how much? Diagonal S is, we want what? Let S be the side. S equal to diagonal. Then, or you do one thing. Let S be a side. Or do one thing. You write, let S be the side. Then, D equal to root 2 times side. See, if you take side as S, see, for example, yes, then your moment of inertia answer is your Ixx, Iyy will be, check the answer. Actually, checking not required, it will come. Ixx, Iyy is D equal to root 2s, see, root 2s power 4 by 12. Just now we got. By root 2s power 4 by 48 as per this formula, or root 2 power 4. Root 2 power 4 is 2 into 2. Root 2 power 4 is 4. Root 2 is power 4 is what? Is 4. 4 by 48 is 12 or equal to s power 4 by 12. Oh, same answer as we got when we considered side s. See, when we considered side s also we got same answer. Okay. Make a note. Now, question 85b, you take one exercise. Find moment of inertia about centroidal axis for a rhombus section. If you study all this, it is useful for your bending and shear stress chapter, plastic analysis, and also competitive examinations. Okay. Section of diagonal, any diagonal 120 millimeter. Okay. I will give answer. You take full exercise, answer. Your Ixx will be equal to Iyy equal to, do the same way. But all will tell, sir is not doing same way. Yes, why should I do same way? I got the confidence. Divided by 48. 4.32 10 to the power 6 millimeter power 4 will come. Correct? 120 power 4 divided by 48. Yes, 4.32 10 to the power over. Now 85 over. Now I will go to question number 86. That is for diamond section. Okay, last one. Diamond section. I will do one thing now. I will write something and then explain to save the time. Now, question 86. 86 or 80, I think 85, I think it is. 1 minute. Last time 84, correct? 84. Last time 84, so it is 85 now, not 86. 85. 85A. Correct, 85? Bookwork is 84A. No. Diagonal given, 86 only, correct? Because 86. Bookwork with side is 86A. Numerical is 86B. Bookwork with the diagonal is 85A. Numerical is 85B. Now, bookwork type with the for diamond is 86A. Find moment of inertia about centroidal axis for a diamond section of diagonal D1, D2. Class. It is not given which is horizontal diagonal, which is vertical diagonal. Okay, we will do one thing. We will take, you write here, let us consider the horizontal diagonal as D1, vertical diagonal D2. You should write it. I am dictating in the class. Those who are lazy, they don't write, they will ask later, sir, why you took this D1? If they give other way, write other way. What is there? So we will consider D1, D2 diameter. Horizontal diameter D1, vertical will take D2. Okay, now see here. Divide into two parts. Two isosceles triangles. See, this is D2. This is D1. Both are equal actually. Complete. Yes, correct. So both are not equal. See, here D2 I have taken more than D1. Does not matter. If that is D2, this is D2 by 2, D2 by 2. Okay, start. I about XX. First I about its own axis. D1 into D2 by 2. Don't cancel 2 and 2. This is suffix 2. This is numerical 2. Okay. Parallel. D1 into D2 by 2 cube divided by 36 plus area into, see, this distance square is 1/3 of D2 by 2 whole square. That is for upper isosceles triangle. Multiply by 2, you get everything. Now you simplify. What is there? D1 into D2 cube. See here also. D1, when you simplify, what will happen? You simplify. See, when you simplify, see, D1, D2 cube. D1, D2 into D2 square is what? D1, D2 cube comes outside. Then simplify. 1 by 8 into 1 by 36 plus 1 by 2 into 1 by 2 into 1 by 9 into 1 by 4. When you square it, multiply by 2, you get D1 into D2 cube by 48. The same way, IYY. I'll write here, okay, space is there. IYY, see. Start. I about, first here, its own centroidal axis, isosceles triangle, be careful. Parallel is D2 by 2, see. D2, no red color. This is a black color only. Red is for H square. It is D2 by 2 into D1 cube divided by 48. Told many times for you. By 40. Visible in camera? Oh, visible, okay. Why this 48 is not that 48? This 48 is not that 48. Isosceles triangle property, I told, plus area, half into D1 into D2 by 2 is the area into centroid lies in YY into 0 square. 0 square multiplied by 2. Calculate. See, d2 by 2 into 2. 2 will cancel. d2 into d1 cube by 48. d2 into d1 cube by 48 is the answer. Now, you make a note here. Make a note. If you can remember it. For a diamond section of one diagonal d1, other d2, see, if you want I about this axis, it is the parallel diagonal d1 into perpendicular diagonal d2 cube by 48. Same way, if you want I about this axis, it is the parallel diagonal, which one? d2 into perpendicular diagonal d1 cube by 48. If you can remember, remember it. Okay, now 86a over, I will give 86b. Numerical. Full exercise, I am not solving. See, once I solve with the unknown values and get the answer, you should solve the questions. Okay, see. Of section of diagonals, see here. 120, one of the diagonal is 150. 180 mm and other one is 240 mm, 250 mm, not 250, little more, 300 mm. And right here, 180 mm is horizontal, so 300 mm is vertical in the question given. Okay, see. Okay, so this you take 180, this you take 300. Okay, now directly mark x-axis. I want directly answer. I will give answer for you. You should solve exercise for you. This is I about yy. What I will do? I will use the formula because I only derived it. Ix is 180 into 300 cube divided by 48. 101.25. But you should not do it. You should solve systematically. Millimeter power 4. Iyy is 300 into 180 power 3 divided by 48. 36.45. 10 to the power 6 millimeter power 4. Okay, now 86C is there. This is also exercise for you. You should solve it. I will start the question and leave it. See. Find moment of inertia about centroidal axis for a diagonal diamond section of diagonals given, correct? Instead of diagonal given for diamond section as shown. See, now difficult to write sketch. Section as shown. As shown. You should solve it correctly now. See, I will give a question for you. See, they told a section this way, diamond section. What they have done is, see, instead of giving diagonal, they have given side 100 mm. Side given 100 mm. And now they have to give the angle. See, this angle, they will give 70, it is 70, 90, 70, 40, 80 degrees. Okay, 80 degrees. That is 80, this will become 100 degrees. No, leave it, 80 degrees over. Now see, what you need, solve the same way right here. We need diagonals. Diagonals, D1 and D2. You write here. This is the given question. Write the question once again. Write question once again. And tell we need diagonals D1, D2. See, diagonal D1, D2. D1 and D2. Then you can solve the question. D2. So what to do? See here. You take this 80 degree given, you take only this triangle. See, this triangle. That triangle. Okay, I write here only. This I can remove. I'll project here. See. this way. This is how much? They told this is 80 degrees. So this angle is 40 degrees. Then this angle is 50 degrees. Okay, with horizontal we'll take angle. This side is 100 mm. And this side will be how much? If this is D2, this is D2 by 2. And if this is D1, this is D1 by 2. D1 by 2. Start. Sin 50. Sin 50 equal to D2 by 2 divided by 100. So your D2 will come 100 into sin 50, that's 76 point something into 2. 153.209. 20888889. Okay, accurately. 89 millimeter. Okay. And cos 50 equal to D1 by 2 divided by 100. So your D1 will come 100 into cos 50 equal to into 2. 128.5575 millimeter. Now solve the question entering these values and solve and get answer. I'll write answer here. Answer is IXX and IYY. Red color is not there. IXX equal to D1 128.5575 into 153.2089 cube equal to divided by 48. You should not use the formula. If you are using formula, what you are solving? You should solve systematically. Lastly, check the formula. 9.6318. 6318. 10 to the power 6 millimeter power 4. IYY equal to D. This is D2. 153.2089 into 128.5575 cube. I can use the formula. You divide by 48. You cannot use it. 6.7816 10 to the power 4 millimeter power 4. Solve the question, get the answer. That's all. This class I am ending now. Now this special type of questions over now. We'll go back to moment of inertia next class. Okay, thank you.